Okay, so in part one, we drew a curve and we attached the placement controller of the rig. We moved the ball up a little bit um, so that it's sitting on the ground. So all that's fine, but how do we calculate the rotation that we need for this? So to do that, what we need to know is how far the ball is going to rotate, and then what the circumference is of the ball. The example I gave in class is, imagine that the path that it needs to travel was a string, right? So we would take this string and wrap it around the ball to figure out how much rotation it needed to do to get that. So we'll come back to that idea here in a minute. So the first thing is, how do we find out how long this curve is? Maya doesn't have a kind of exposed tool in the menu to do this, but Maya does have other tools embedded within its kind of programming language. So if you do a little search online, you might find this. So here's an example right here. So from the Autodesk site, there's a little command in Mel, which is Maya's embedded language, right? That's called arc length. So it's basically the length of an arc or a curve, right? So arc len. So if we use this as a command, Maya will tell us what the length of the curve is for us, right? So how do we do that? While I'm here, I should mention just down below, underneath the preferences here that we've been using, as I like to joke, man running from saw blade, we have the script editor. So the script editor is whenever I do things in Maya, so you can see I selected the curve, or cleared the selection. I selected the thing called pillar, right? So these are in here. This is a helpful tool later on if you continue to use Maya for speeding up your kind of workflow. But the mini version of this is down below, where we have the Mel script kind of command line, and then the output. It's kind of like the little console window. So how do we get this number that we need, right? What's this length? So we're going to type out that command as we saw it, right? ARCLEN, so arc len, or the arc length, right? And then hit spacebar, and then I'm going to tell it what it is I'm trying to measure, right? So curve 1, which is the name of that curve that we drew into our scene, right? So if I just hit enter, it will give me a number down here. And I'm going to go ahead and write that down just so that I can remember it for my calculations later on. So 62,450. 3 decimal points should be just fine, right? Okay, so the next thing we need to figure out is, what is the circumference of the sphere itself? There are some measurement tools I could show you. I went ahead and used them. You could put a sphere in there and try to scale it so that it was the exact same size. But basically this ball is just under 2 units big. I don't know why it's slightly less than 2. Again, this rig was created by someone else, but for all purposes, the diameter is 2, which is totally fine. And I'll put this in the notes on Canvas, but if you look this up online, you will find that to calculate the circumference of a sphere, you can either take the radius times 2 times pi, or in this case, you can just take the diameter, right? The radius times 2 is the diameter. So from one side all the way through to the other side would be this, and then we would multiply that by pi, which is 3.14 is what pi is. Bonus points to one of the students in the 1230 class that could rattle off many digits of pi. That was pretty impressive. But we just need 3.14 would be fine, right? So let's pull up in the calculator here. We've got all that all cleared. So let's say we have 3.14, right? That's pi times whatever the diameter is here. It's very easy, right? We're going to get 6.28. So this is not always the number, right? When you have a sphere, if we had pi times, let's say the sphere was 4.79 was the diameter of it, right? Then we would get 15 or something like that. So but we already did the math, right? 6.28 happens to be the circumference of this sphere, right? So how do we figure out what that means to the length of the curve, right? So let's clear that, and I'm going to do the length of the curve is, mine is 62.450. Yours certainly will be a different number. So that's the length. And then what I need to do, just like that little example of the string, I want to figure out how many times I wrap this string, which is the path, right, around the ball. So to get that, I'm going to take its length and see how many times it goes around that. So we have, this is the length, and then I'm going to take it and figure out how many times 6.28 goes around it, and it will give me a number. So it's a nice long number, so 9.944. So what does this mean, right? So we're talking about the circumference itself, and every time that circumference makes it around the length of this, that's one, but one what, right? One complete rotation. So how many degrees are in that rotation? 360. So we're going to do 9.94 rotations. So if I take that amount and just multiply it by 360, right, that will tell me how much rotation I need to do to travel along that, so that the rotation matches the distance traveled. So let's write that down so we don't forget it, right? So 3579. I am actually writing this down so I don't forget this during the tutorial, and I'm just going to go 2 decimals in, right? 0.93 should be fine. All right, so I don't need the calculator anymore. Okay, so the one thing about this is that as it rotates around, based on the animation, because we're going to do this little bounce to land on top of the pillar, I would like it to look like the ball intentionally rolls up to the pillar oriented. So I always think of this as kind of the head, right? And the foot, because we're going to do this squash and stretch, right? And we can reorient these in certain ways, but I'm going to treat this ball as a sentient being that knows that it wants to roll up to that distance and end face forward, as it were. So what I'm going to do is go to frame 90, because that was the final length of the animation, right? I'm going to zoom in here, and that was a little weird. I don't know where my ball went. I'm sure there it is. It's just freaking out in the editor view here. Let's go back to, let's try flat shade all. Maybe I need to turn off my ambient occlusion and smooth shade. All right, trust me, it is there. It's just disappearing. Oh, actually, it did go away. Let's see what Maya did here. All right, so it is there. It's just Maya freaking out. Okay. So in earlier classes, I talked about using the move control and not using the rotation. But for various reasons of how the ball rig is created, if I try to do the rotation with the rotate tool, in this instance, based on the way the constraint is working, it will not work. And it's kind of complicated to explain. So just trust me, in this instance here, we've taken the control 6, and we're going to constrain that and leave it on the curve. But in this instance, I want to actually use the rotation for the ball move control, right? So I'm going to come up, and I've moved to frame 90. And I'm going to come up to the rotation, and I'm going to keyframe all of those, right? And just put a key there. And then I'm going to go back to frame 1, frame over there. And now that rotation, or the amount of rotation was 3,579.93. Again, that's mine. Yours will be a different number. But because I'm working kind of backwards from the end to the beginning, I need this to be the negative amount so that it rotates in the right direction. So negative 3579 point. Oops, I got a different 39.93. All right. So then I'm going to put a key for all of that, and let's see what happens. All right. So that looks pretty good. It seems to match the curve. Everything looks good. It means I did the math did it correctly. And I can check this too, interestingly enough, if I go to the animation setup And what I want to look at is the rotation here with the motion path. So I have this selected. In fact, let's start it the other way. Let's select the locator, and I'm going to click on the motion path, and then I'm going to hold down Shift and select the ball move control. And if I scroll down, so this is I'm going to click on rotate X, and I'm going to click the control for the rotate X, and then I'm going to hold down Command on a Mac. This will be different. It'll be Control on Windows. So this shows me the two curves, and you can see I had the interpolation set to linear for all this. So I'm going to select both of those and hit flat, and I'll select the ones here at the end, and I'll hit flat. And keep in mind the length of the curve as it travels along here is from 0 to 1, and then the rotation's from 3500 to 0, right? So I see vastly different curves, but our new friend normalized view, where did the U value go? So this is confirming that everything's working because the U value is actually sitting right underneath, and they match perfectly with each other, which just because the normalized view goes from the minimum and the maximum, you can see that they are working in tandem with each other. And I can also do the stacked view. Oops, let's get the U value. You can see that now they're right next to each other, and they're just perfectly in sync, right? All right, so I get a little ease in and ease out. So if I get to the point I feel like, hey, you know, this is it's moving too fast, I could always say select all those keys. So this is all the rotate values and the U value. Instead of going to frame 90, I'm going to make it go to frame 120 and stretch that out. I'm going to make my time slider a little bit longer. Right. So you can see it's just rolling a little bit slower. Right, so you can make any edits that you would want in here. You could even have it move in here and stop at one point and then speed back up again. Just remember that the rotation now has to look exactly like the U value because these are connected with each other, the distance and the amount of the rotation. Okay, so from this point on, the rest of the animation would be about just using the move control to do whatever bouncing and squashing and stretching you want for this part of the animation. I would advise just leaving the placement node just where it's at. We don't really need it. It's done its job. It moved us along the curve. It's still constrained to the curve, right? So, as long as we just leave it where it's at, we can animate from that origin point and be just fine. Okay, hope that helps.